Okay, thank you, Naomi. Good afternoon, everybody. So, at the High Value Manufacturing Catapult, for those of you who some know us hopefully, and some maybe not, we work on across a network of 7 centres nationally, taking technology, manufacturing technology from the research base and from innovative companies and maturing that to a point where it can be exploited for industry. So really bridging the valley of death, the manufacturing valley of death, that mid-tier aerospace. And as you might expect, across our 7 centres, around about 3,000 manufacturing engineers we've got across the network. We're doing a huge amount of work currently in the digitally enabled manufacturing technology and working broadly under the banner of Industry 4, amongst other technology streams we have in place. So today, I'm going to talk to you a bit about some of the new business models and perhaps touch on the revolution versus evolution arguments around Industry 4. So first of all, if we're talking about revolution, a revolution generally is not led by the person who sat in the throne at the time it starts, and it's always transformative. It's really going to change the landscape. So no single piece of technology is going to do that, but what we're so the technology itself is an evolution, a number of pieces of technology that make up essentially the jigsaw picture, which in itself builds a revolution from a business model perspective. So in terms of the 4 industrial revolutions, rather than go through each of those 4 in some detail, I want to talk a bit more about what we think Industry 4 means to us. So the underpinning technology pieces would include greater connectivity, data analytics, so of course the industrial Internet of Things, and a large swathe of technology including things like robotics, collaborative robotics, augmented reality, virtual reality. So it's really a suite of tools that mean we can start to embed intelligence. And if the 3rd industrial revolution was around automation of manufacturing processes, the 4th is around automation of decision making, essentially autonomy. So these suites of tools come together to transform a landscape and really transform potential future business models. So there's a short-term opportunity just to change the performance of your manufacturing businesses at the moment. There's almost a 2-speed approach, I would say. So one is looking at how you improve productivity, reduce lead time and agility within the factory bounds and within your own control. And the other is looking at how the landscape is changed in terms of connectivity through supply chains across factories with the consumer base and some of the digital disruptors that may start to change marketplaces. So if in the world of the 3rd industrial revolution, we start to look at automation of processes, and we still have many manufacturing factories around us where manufacturing engineers really are instrumental in making a process work, making parts. If we've got manufacturing engineers who think they've done or operators who made their contribution that day by helping to craft and make a part, that is of a past time. Really, we see the world of Industry 4 being where the manufacturing engineer and the operator in the factory environment is building, maintaining and interfacing with manufacturing systems. So essentially, people make systems and the systems make parts rather than people making parts. So the technology is here now. It's an evolution in terms of technology. And the pieces of technology we have around us can certainly transform business performance in the near term. The revolution comes in how you pull these pieces together and start to change the landscape and change business models. So in terms of revolutionaries and disruptors, I think this is a fairly well-known brand of a real disruptor. If you think about Uber and what they've achieved in the world of transportation and taxis. So this is the world's largest taxi firm. They don't own any assets, no vehicles, certainly. And comparably, you think about maybe Airbnb, who are the world's largest hotel firm, who don't own any physical infrastructure or hotels. So these guys are embracing the power of digital platforms and technology and networks, bringing markets and customers through to the providers. So incredibly disruptive in their own space. Maybe not directly relevant to manufacturing, but I'd say there's 2 ways in which we could look at this could change the manufacturing landscape. So one is you may get an Uber or an Airbnb coming in at the top of your supply chain in the markets in which you're operating and transforming that market. And the place you hold in that supply chain may fundamentally change the way you need to behave, the way you engage with your customers, your own suppliers, and the consumer base. So a disruptor come in from left field and fundamentally change the landscape in the way that Uber have done that for taxi drivers and Airbnb for hotels. Or equally, there may be an Uber or a Facebook or a Makebook who comes into the manufacturing environment and actually starts to be that middle player who generates the value. So where the value perhaps will come from accessing to data, connecting makers and manufacturers with potential customers and suppliers, and maybe starting to move away from the conventional vertical supply chains. So looking at where may newcomers come in, the revolutionaries in the manufacturing domain may be the existing players moving in there, but a good chance that some of these will be people who aren't currently in the manufacturing domain, coming maybe from the strong digital technology sector we have in the UK or globally, and finding a place where they can derive value and embed knowledge and intelligence in software systems and solutions that will transform manufacturing behaviour. So you think about where the technology is coming from. So you've seen today some examples of manufacturing technology, data analytics that's starting to change the landscape from a manufacturing perspective. If you look at some of the disruptive players like Ocado and Amazon, again coming from the consumer markets. So Ocado are leading the way now in terms of logistics and the factories they've built to meet the challenges required just to meet their market demands. We've now got Ocado Technologies as spin-outs. So logistics and robotic solutions that are actually being born from the consumer market that are now available to a wider audience beyond logistics into the manufacturing domain. You think about what Amazon are doing in terms of the cheap sensor technology and drone technology and pushing this forward, as well as the Amazon analytics functions and web services. You've got things like the Amazon Dash. So the example where you can go and press a button on your washing machine when you're out of powder, or the beer button in your fridge, and have that next delivery come via drone. This is technology that is being piloted now and will be there for us as consumers in the real world in the very near future. And this is technology that's being driven at a price that meets consumer markets. And this technology is available now to the manufacturing domain as well. So transformative in the way it's changing markets, revolutionising the way we do business, but also spurring discrete pieces of technology which we can draw into our manufacturing domain and factory domain at much more affordable cost than perhaps we could from just within the manufacturing community in itself. So going back to the manufacturing domain and looking at how we couple, so manufacturing often seems discrete from perhaps design and in-service performance and consumers, and thinking about the digital thread. So really coupling the design function into the manufacturing domain and into in-service use is an important part of where the value comes. So it's connectivity through the value chain. You've got firms such as Autodesk pioneering these initiatives of recognising the value of the design tool and coupling manufacturing intent at the design stage. So you can start by designing, in this case, a car or a vehicle, and think about embedding manufacturing knowledge at that stage. So rather than design for manufacturing being a means of tweaking a concept design to make it more manufacturable, actually building your manufacturing toolkit and your concept design based upon manufacturing intelligence embedded in that system already. Then you move on to visualization and using things like VR tools and AR tools to make sure you're fine-tuning that for end user use. And also looking at taking it all the way through to a digital twin. So normally these models are developed at the design phase of a component or a factory or a process. But one of the opportunities we have now with digital twins is to take those models beyond the design phase and through life, which may be through the life of the asset, through the life of a factory, and actually put real-time data in there to embed intelligence and automate decision-making. So using real-time data to augment the models that are normally built at design stage to make real-time decisions in your factory environment or perhaps in a product environment. So beyond just the product design and digital thread, and thinking about what we do in a factory environment. So we're using these digital twins and digital models to design factories, using things like VR and AR tools to represent, not only simulate how a factory is going to perform in terms of discrete event simulation and performance of the line, but also walk around and test the factory, start to do mock-ups of tooling before all the components are available to us, drastically reducing lead times and improving right first-time commissioning of kit, of assets, of factories. So a big part of the enabler of the technology we see is this agility, really reducing lead time, reducing the time from concept to consumption. And the manufacturing part of that is a standard as well as it does for the product life cycle. So we're developing tools for simulating discrete processes, simulating factories, and simulating products, and using those, taking those through into the life cycle of the factory or the product as digital twin, where we can bring real-life data, combining data analytics with a more traditional modelling, simulation, and physics-based models to provide powerful decision-making tools. So these self-learning systems are all the time evolving, improving the way we design our products and design our manufacturing systems and design our factories of the future. So here's an example of a layout of a factory of the future. This is built around Factory 2050 in Sheffield, which is one of the facilities in the HVM Catapult network. And we see this being built around a factory information bus, so that connectivity being the centre and the hub, really, of the whole factory network. And this is then connecting to the devices. So the top left-hand corner there, you see examples of AGVs, robots, cobots, machine tools, that are data sources. So we're monitoring the uptime and the health of the equipment, monitoring the health of those processes, feeding that into the information bus, and also feeding back into the to the human operators or manufacturing engineers or production engineers. So the human in the loop is a really important part of the system here. We see that role changing again from making the process work to maintaining and interfacing with the process. We see augmented reality being a really important part in cooperative robotics, where perhaps full automation doesn't stack up, but being able to use humans as clearly skilled and dexterous, dealing with the complexity and customization and variety that may come through a manufacturing line, but using digital instructions through augmented reality, through projections, through tablets, through headsets, to instruct and ensure a robust and agile process. And also providing reports to management to make decisions. So there could be a step here to the assisted decision making, or ultimately the move to a fully automated digital twin of a factory, where all the data we're feeding in can start to, rather than provide reports and intelligence to a manufacturing executive, actually make decisions and self-adapt the factory around changes in terms of machine health and process health, changes in terms of supply chain, mapping what's happening in the logistics network, changes in terms of demand from customers, as well as the supply from our suppliers. So this information bus is mapping what's happening in the factory, it's communicating with the engineers working in a factory, and it's communicating what's happening down the supply chain and from the customer base and consumer base. And we see this has been an important framework around which we build the future intelligent factory. So this is the ultimate vision, an intelligent factory that can make these decisions for you and lead to a fully optimized and efficient factory environment, but it's made up of discrete pieces of technology that are available here and now. So a great way of visualizing what we think this future factory would look like is to take the comparison between Google Maps and a conventional map book. So here you've got an example of a London A to Z, and you've got an example of Google Maps giving you the route. So if we start off with the analogy between trying to get to destination A to B and working in a factory environment in a more traditional pre- and I4 factory, taking the journey, I might know from memory or from knowledge, I might have a good idea of where it is I'm trying to get to, and I've got maybe a printed route card which is set at a point in time. The information was right at the time of printing, and it's there as a reference document. I should be following it, but perhaps in reality I know what I'm trying to execute, and that's there as a backup and a reference, and it will take me through at that point in time to the right outcome. Problem is that is out of date the moment it's printed, very inflexible in terms of schedules changing. And we take the example of Google Maps when I'm trying to get from A to B. I start off by saying, well, it knows where I am to start with in a point in time. I tell it where I'm trying to go, and it gives me, based on aggregated data sets, so large volume data, a potential 2 or 3 routes to get to my destination. Choosing the best route based on aggregated data and system learning, it will then look at, in real time, what are the implications in terms of traffic conditions, and start to give me, once I select the route, the information I need at the right time as I go. So no longer worrying about the map or my knowledge or what I need to do. I'm just executing the tasks that are instructed to me at that point in time. And this is the way we see the future factory working. You're using aggregated data and learning to map out the optimum process route and manufacturing system and parameters, but then using real-time data to fine-tune that and give the information that's required at a given point in time to either the machines or the operators or the manufacturing engineers or production managers who are executing that system. So ultimately, this is the kind of integration we'd see of the future factory and the future supply chain. Great parallels to Google Maps, and it's really around the power of data and the networking effect, or network effect. So think about the business models that enables beyond the factory. So we already see changes in business models from to servitization, so moving away for large value assets from point of sale price and building and manufacturing a system engineered around a point of sale price, to looking at servitization, which makes you think differently about the assets you're building. So Rolls-Royce already, over 50% of their value is generated from, or their market is generated from servitization and power by the hour. So it's a very high value complex asset and a great place to start with this. But the model starts to change and changes the way you go around designing, manufacturing, and the relationship between the data that you get from in-service performance of an engine, the data between the manufacturing process in the shop, and how that feeds back to the design stage. So maybe moving away just from binary tolerancing of components, but starting to look at qualitative data around how we make components and how they relate to the performance in process. So the evolution here towards servitization for large value assets, we see probably that the value class coming down, at which we might start to move to servitization. We talked about Uber earlier as a model that's changing the landscape from a personal transportation point of view. Now Uber are supposedly looking at ordering a large fleet of autonomous vehicles, and if Uber start to move to the providing a service, so I think in New York, there's various parts of New York where it's been, economists are saying, well, actually the Uber model is more attractive than owning your own vehicle. So just using Uber and renting that service as you need it is more attractive than owning your own vehicle. So again, moving potentially to servitization in the car industry. Now, if that was to happen and the commercials stacked up, it changes fundamentally not only the way you work as a consumer, but as someone who's designing and making or working in a supply chain for automotive. Certainly going to have less cars, but they're going to be much higher value because you're now building through life, and you're thinking about evolving and potentially upgrading the technology through its life cycle. So looking specifically around cars now and the intelligent vehicles that we have around us, there's huge amount of intelligence embedded into these relatively medium assets, value assets, let's say, high value as a consumer, but maybe medium asset class in the wider markets. So we can gather data around the performance of the engine, the usage of that vehicle, and start to think about how that engine is performing. It's providing information back potentially to your insurers, to various stakeholders, to you about how you're driving, and certainly back to the producers of those vehicles, who can start to fine-tune and look at the next iteration of how that vehicle should be used. So you look at the Tesla model, for example, now, where you're looking certainly from a systems and software upgrade, based on the data they're receiving around vehicle performance, you're going to get an upgrade to your vehicle performance from a control systems point of view. And it's not a huge leap to think how you can move then to actually upgrading mechanical systems on cars and on other assets classes. I mean, this can move to the stage where you're actually servitizing your washing service rather than buying a washing machine. And your upgrades in the software and control functions, but also in the mechanical functions in your assets as well. And you think about additive manufacturing and the ability to derive value and knowledge from the data we're going to gather from in-service performance and manufacturing performance to evolve and improve iteratively the subcomponents as well as the overall performance of the assets that we're working with. So this has the opportunity to transform the landscape. It's already there in terms of large value assets, and we see servitization, I think, is going to really start to tip in different asset classes as well, which will change the way that we design, make, and serve the market. Absolutely. So that's a revolution we see coming potentially in terms of business model changes, in terms of the consumer markets and the markets we're serving, as well as a revolution in the way that companies interact and behave, and a revolution in the factory place. So, although the revolution in terms of business models is what's going to really transform society, there's an evolution in terms of technology, as I said earlier. Many of these pieces of technology are around us now, some born of the manufacturing environment, be it robotics, analytics, VR and AR systems, some coming from a gaming or a consumer market. These pieces of technology are around us now, and you can start small and invest in pieces of technology that, on specific projects or activities within your business, that will just improve productivity, reduce lead time, improve agility, and actually start to build a framework whereby you're well set to exploit the opportunities that come from connected marketplaces, connected supply chains, improving agility and reducing that cycle between a customer inquiry to delivery by starting to improve productivity and connectivity within the factory, but also starting to explore the opportunities that come from beyond the factory through your supply chains and into new business models. Now, the UK, we believe, is extremely well placed to exploit this. We've got a rich landscape in terms of research, a research base, a world-class research base in the UK, an academic base, a great research and innovation structure with like the catapults, the HVM catapult, digital catapult, and a healthy base of RTOs here as well. So a very healthy landscape in terms of research and innovation. We've also got world-leading sectors still in terms of automotive, pharmaceuticals, world-leading factories in terms of automotive, of course, and aerospace being number 2 in the world still in the UK. And we've got a world-leading digital technology sector. So some of these disruptors, an opportunity may come from marrying companies coming from the digital tech sector, maybe diverting their gaze from fintech and gaming, and seeing the opportunity that may come from capturing knowledge and expertise in a manufacturing environment, which I heard speakers saying earlier today, is perhaps much of that exists in an aging demographic, in the heads and the knowledge and skill sets of individuals, and capturing those and building systems which mean that there's knowledge at a system level within our organisations and our companies that can lead to greater productivity, greater agility, and greater market share won within the UK. So we are extremely well placed in terms of the creative and innovative nature of our nation, the digital and tech sector that we have, a very strong pedigree in manufacturing and a brand manufacturing for Britain, which gives a great opportunity to exploit our capability in a wider global marketplace. There's a few initiatives running at the moment in the UK. So we've recently had the Green Paper launch for industrial strategy, and within there were 5 sector reviews announced, one of which was the Industrial Digitisation Review, being led by Jürgen Meyer. This is just kind of getting underway now, reporting out in July and looking potentially at a sector deal for industrial digitisation, digital manufacturing for the UK. So there's real focus here on a ministerial level and at number 10 level for where digital manufacturing could transform and play a role in the UK, and particularly in a post-Brexit economy. So this review is looking at a number of sector or technology verticals and trying to gather evidence to see where people were embarked on digital journey, to see where evidence for success, how can we replicate that success, and where there's been barriers around maybe standards, skills, access to finance, access to knowledge, where are those common threads that can feed into these cross-cutting themes and deliver an industrial strategy around digital manufacturing. So that's an encouraging initiative being led by Jürgen Meyer. There's also an industry leadership group around digital manufacturing, which I'm currently co-chairing. So some major players across 5 different sectors. This is growing at pace over the last 18 months, and done a lot of thinking and working around where those opportunities and barriers exist in the UK, and launching an outreach programme, and also currently mapping capability, starting across the catapults and the universities, but also at case studies that exist across a wider industrial landscape. So one of the key bits of feedback I've got when we talk about Industry 4, and I talk about business model transformation, which may be exciting but seem a long way away, is show me the technology and show me what it can do for my business right now. We're mapping those examples of good uptake of technology across the Catapult network, universities and industry, so we can have some peer-to-peer learning and see those opportunities lie to exploit digital technology. So as part of that, there's an app we started to develop within the HVM Catapult. If you want to flip to the app now, and this is mapping, it's a pilot at the moment, mapping within the Catapult network some examples of Industry 4 technology and digital technology that has already been realising value for companies that we're working with within our network. Our plan now is to expand this so you can view it by sector or by technology or example, or where you're on the life cycle through from design, manufacturing and in-service monitoring. And we're building this network up, only a pilot right now, and it's going to expand into looking at universities, demonstrators and capability, and also, most importantly, a series of case studies across the UK, so we can map capability and signpost people to the right next step. So a bit of peer-to-peer learning. So it's quite a powerful network we have already in the UK. We're trying to draw that together so we can evidence the power of the collective that we have, and really working with government, with the strategy, with collective industry groups. We think we're phenomenally well placed to lead, as we did on the first, in the 4th Industrial Revolution within the UK. So please, if you want to come and see the apps, come to our stand. You can explore this in more detail. Colleague Daniel's at the back now, and he'll take you through this on the stand. But we've got examples of technology on the Innovate UK stand to show you some of the discrete aspects of that, and we're happy to talk more about the opportunities of your business, where we're seeing things going in the future. Thank you.
Samton.